Okay, this is section 5.4, video number 1, polynomial and rational inequality. And we have two objectives. First one, it's going to be solve polynomial inequality and the second objective is solve rational inequality. Okay, so let's start it with the example. Let's start with solving polynomial inequalities. And the example 1, solve polynomial inequality using its graph. So this one would be much easier if we'll have a graphing calculator and we can graph each polynomial inequality as a function, and then you can read the solution from the graph. So I want to show you the example how to solve that inequality using the graph, but in our class we'll focus mostly on solving them algebraically. So you have x plus 3 times x minus 1 to a second power, which is greater than 0. So on the left side, what you have polynomial function of degree 3. So what we can do, first, graph the function. And the function is the expression on the left side of the inequality, f of x equal x plus 3 times x minus 1 square. Okay, so technically you're graphing y, it's equal x plus 3 times x minus 1 square. Polynomial function, they are a little tricky to graph. I'm going to show you how the graph looks like, because I want to just explain, when you guys see it on the graph, what is the solution of polynomial inequality. Okay, so we have 1, there's a point right here, 3, that's the y-intercept, and then negative 3. So there are 3 nice points. Here the function goes down, then keeps going up. It has the maximum over there. Go down, then touch the x-axis and continue going up. Something like this, okay? And also you have the graph on PowerPoint section 5.4. So when we graph it, second, what you're going to do next with that graph, you have to determine the intervals of x for which function f of x equal x plus 3 times x minus 1 square has positive y values. Okay, so let's go back. This is our original polynomial inequality. Like you see, we have x plus 3 times x minus 1 to a second power. We'll graph that function. The inequality symbol, this is strict inequality. This function has to be greater than 0. So technically, when you're solving polynomial inequality, you're looking for intervals in terms of x-axis for which the y values are positive because we have greater than 0. So we're going to look for the first on the graph, you're just checking where function has positive y values, which is right here. Okay. And now you have to describe that using the x values and intervals. Okay. So again, let's just write that originally. Our inequality was x plus 3 times x minus 1 square greater than 0. And solution of this polynomial inequality are all x values. Because don't forget that you solve that inequality in terms of x, so all x values from intervals. And let's go back to the graph. You see the function's positive for x values from -3 to -1, and then from 1 to positive infinity. -3 to 1, union 1 to positive infinity, which is the same as -3 to positive infinity. Okay, so when we have a graph, it's very nicely to see the solution. You just need to graph the function, polynomial function. And then since we have greater than 0, so you're looking for the graph which is above the x-axis. And when you write the solution, you're using the x values because, again, your inequality is only in terms of x values. So this function has positive y values for all the x from -3, including -3 to positive infinity. So those who have calculators at home, you can always check your work. However, in this class, we're going to solve them algebraically. So example 2. Solve polynomial inequality algebraically. Okay, so that's what we're going to focus on. And we're going to do a couple examples. A, it's x to the power of 4. It's greater than x. And let me write all the steps. So step 1, rearrange the inequality so 0 is on the right side. So inequalities, you're solving almost the same like equations. So the idea is to have a 0 on the right side. So in our case, we have x to the power of 4 greater than x. I will subtract x from both sides, and that will give us x to the power of 4 minus x is greater than 0. So this is the inequality with which we're going to work. So step 1, we rearrange the inequality. Step 2, find the x-intercepts of the equation which you have on the left side. Okay, so we need to find x-intercepts of the equation which we have on the left side, x to the power of 4 minus x. So how are you going to find the x-intercepts? You're going to change that inequality to actually equation. You're going to make that equal 0. And to find the x-intercepts, it's polynomial inequality, you will need to here factor out GCF, greatest common factor. So the greatest common factor between x to the power of 4 and x is x. So factor out x, and we'll end up with x to the third power minus 1 equals 0. So now when you have a product of two factors equal to 0, you're going to use zero product property, which means that x has to be equal 0, your first factor, or x cubed minus 1 is equal to 0. So x equals 0, it's already x-intercept. Here we need to solve it. It will be easier for you to solve if you move 1 to the right side. So having x cubed is equal 1. And to solve for x, you will need to take the cube root of both sides. And cube root and exponent undo each other, so you have x equal 1. So when you take the cube root of the number, it's only one solution. So we end up with x equal 1. So that's also x-intercept. Okay, this is also x-intercept. So what you're going to do with those two x-intercepts? So this is the idea. We're not going to graph those inequalities because we're not using the technology TI-84, but we're trying to get the 2 points, the x-intercepts, the points which are on the x-axis from our polynomial inequality, so we can actually decide for which x values our function, in this case, because that's what we're solving, it's positive. So we're trying to decide for which x values our function has positive y values, okay, without graphing. Okay, step 3. Use the x-intercepts to build intervals. Since we don't have a graph, we're going to check which intervals satisfy our inequality. So this is our x-axis. Our two x-intercepts was x equals 0 and x equal 1. Let's go back to our inequality. Don't forget that this is what we're solving right now. X to the power of 4. I'm sorry, not this one. That's our inequality. We're solving this one. X to the power of 4 minus x is greater than 0. So our inequality, is x to the power of 4 minus x is greater than 0. So a couple things, okay? First of all, we have strict inequality. What that means, that those points, our x-intercepts, are not going to be included in our intervals, which will describe the final solution. So that's why I keep the circles open. Now, your x-intercepts divide the number line into 3 intervals. And now you just need to check which of those 3 intervals will satisfy our inequality. So we're going to check that. This is negative infinity, here's positive infinity. So we're going to check that by plugging in the points and check if they satisfy our inequality. Okay, so step 4, it's the most important step, test. So what you're going to do, select a number in each interval. And evaluate okay, maybe let's do it. And substitute for x from our inequality, which is x to the power of 4 minus x is greater than 0, to check if satisfy our inequality. So maybe let me explain it. So now we're going to pick any number from each interval. We're going to plug it in, substitute for x, and the interval will be the solution if we're going to get, in our case, positive number. Okay, if we're going to get negative number, that means inequality is not satisfied, and that interval from which we pick the number, it's not going to be the solution. So let me show you what I'm going to do. Okay, so I'm going to copy. This is negative infinity. Here we have positive infinity. Of course, this is number line in terms of x values. The first x-intercepts was x equals 0. The next one was x equal 1. Since we have strict inequality, we're not going to include them as part of the solution. Those x-intercepts divide our number line into 3 intervals. So what we're going to do first. So my first interval right here, it's from negative infinity to 0. So I'm going to pick any number from that interval. So any number between negative infinity and 0. So pick x equal negative 1. And we're going to substitute that negative 1 into our inequality. So this is our inequality. So I'm going to replace x with negative 1. So I have negative 1 to the 4th power minus negative 1. And I'm checking if that will give me positive numbers. I'm checking here. So that will be 1 plus 1 Definitely it's positive. So we're getting 2, it's greater than 0, which is true. And when you're getting the true statement, that means this interval is the solution of inequality. So interval from negative infinity to 0 is the solution. We cannot stop. We're going to continue. So next what you're going to do, you're going to do the same thing for the second interval. Your second interval is from 0 to 1. So you have to pick x, which is in that interval. So pick a number from 0 to 1. I'm going to pick x equal 1/2. Plug in, substitute 1/2 with the x from your original inequality. So you're having 1/2 to the 4th power minus 1/2. And you want to check if that will give you positive number. So we're getting 1/4 minus 1/2. We're checking if this is greater than 0. 1/4, 1/2 is the same as 2/4. Check if this is positive. You end up with negative 1/4, which is not positive. So negative 1/4, definitely it's not greater than 0. So this is not true. Since this is not true, the interval from 0 to 1 is not the solution. So interval 0 to 1 is not a solution. And next what we're going to do, I'm going to do the same type of work for the last interval. The last interval is from 1 to positive infinity. So you're going to pick any number which belongs to that interval. So I'm going to pick x equal 2. And I will go back to inequality, plugging in 2 for x. So you have 2 to the 4 minus 2, and you're checking if that will give you positive number. So we're getting 16 minus 2. It's definitely positive. So 14, it's greater than 0. This is true. So yes, interval from 1 to positive infinity satisfy our inequality. So interval from 1 to positive infinity is the solution. Okay, so let's write down the solution. So the final answer. So we're having, using interval notation, okay, the solution of this inequality is the interval right here from negative infinity to 0, union, and the second interval, which we check and we know that it satisfies the inequality, it's from 1 to positive infinity. And 1 to positive infinity. Okay, so I'm going to stop, and later you're going to see the video 2 from section 5.4.